Hello, welcome to today's webinar. We're happy to have you with us for this Getting to Zero session, the Insider's Guide to Talking About Carbon Neutral Buildings. I'm Connie Empress, Communications Manager here at New Buildings Institute. A quick acknowledgement of the sponsors you see here. Their support of this webinar series provides ongoing opportunities for knowledge sharing around actionable solutions to drive the highest levels of efficiency in buildings. First, you're muted and we cannot hear you. This helps keep the background noise down so everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. We will take a few questions at the end of the presentation. Please ask questions in the same question pane. Please take a moment to answer the survey at the end of the webinar. We consider your input in the planning of future sessions. If you are seeking AIA credits, this survey is where you will share your AIA number for credit submission. The session is being recorded. All registrants will receive an email tomorrow with links to the recording and slides for the session. If you need a certificate of attendance for your records, it will also be part of tomorrow's follow-up. If you are not familiar with New Buildings Institute, we have been working in the energy efficiency space for nearly 25 years, working to make buildings better for people and the planet. Here's today's panel. I will pass the mic over to Narada Golden from WSP, who will kick off the presentation today.
All right, thank you. Hi, everyone. Good morning, good afternoon. So we're really excited to talk today about this Insider's Guide to Carbon Neutral and Net Zero Buildings. I am Narada Golden. I am a Vice President and the National Director of the Built Ecology team at WSP, where we focus on incorporating sustainability, health, resilience, and equity in the built environment. One of the things that we are finding today, and hopefully one of the reasons that many of you are in this session, is that a lot of people are talking about carbon neutral and net zero. And it means a lot of different things to different people out there in the world. So we have been experiencing a lot of meetings like this where somebody may say their project needs to be net zero. And people ask questions like, are we talking about energy or carbon? Can't we just buy offsets? Do we need to focus on energy efficiency? Are we including embodied carbon? Which metric are we talking about? How are we measuring it? And ultimately, the guide is intended to help clarify some of these things for folks navigating the world of net zero and carbon neutral buildings. One of the exciting things that's happening in the industry is that organizations are really talking a lot about net zero as well. And this has led to a bit of confusion because companies are trying to achieve net zero carbon by 2050, 2040, or 2030. And folks within those organizations are then wondering if their buildings also need to be net zero. There are initiatives to help define what net zero means in the corporate space, and that is turning into and informing programs to achieve carbon neutral and net zero energy buildings. We are also seeing a lot of discussion around net zero within cities, and you can't talk about a net zero or carbon neutral building without talking about the infrastructure that it is connected to and the various support systems for that particular building, primarily that energy infrastructure. But today we're talking about defining carbon neutral buildings. And what we know is that there are a lot of different elements within buildings that are associated with greenhouse gas emissions. And some of those include things that are connected to those buildings like electric vehicles, how that building interacts with the grid, the various types of fuel that are used, and how that impacts greenhouse gas emissions on the site and throughout the grid. One of the things that we did working with NBI was to look at the many different definitions of carbon neutral and net zero that are out there. There has been a lot of work done to define approaches to achieving net zero carbon and energy buildings. But if you dive into the different frameworks and certifications, they can be quite confusing. Here you can see some of the many frameworks that we evaluated. And one of the goals was to identify common themes in these different frameworks that help us inform foundational elements for net zero energy and carbon buildings. So the frameworks that we looked at included the ones developed by the International Living Future Institute, the Living Building Challenge, the Zero Energy and Zero Carbon certifications. We also looked at LEED Zero for energy and carbon, Zero Code, the World Green Building Council's definition, the AIA 2030 commitment and 2030 efforts, and a number of other frameworks that were working to define carbon neutral and net zero. What I'm going to do is walk through some of the common themes and variables that we found in those as a lead into a discussion about the guide and ways that you can navigate and work with your teams or clients to kind of move projects towards true net zero energy and carbon goals. So one of the questions that is defined in all of these frameworks is how you actually measure the achievement of net zero or carbon neutral buildings. There has been a big push in the industry to prioritize performance and measuring real performance in real buildings once they're in operation. This is how success is measured for the ILFI certifications, Living Building Challenge, Zero Energy, and Zero Carbon, as well as LEED Zero for energy and carbon. But there are some frameworks that look at design-based or prescriptive measures to achieve net zero. And the difference there is those are built off of kind of analysis and modeling that defines how you get to a certain target that can be more efficient and effective when thinking about large portfolios. But ultimately, what most clients want to know is that their building is performing in the real world, and most buildings measure that over a 12-month period. We also looked at whether the measurement was either energy or greenhouse gas emissions, and whether it was site or source. Living Building Challenge and Net Zero Energy, for example, measure and require in most cases that you're producing enough energy on site to meet the annual needs of that particular project. But other frameworks like the Zero Carbon certification look at greenhouse gas emissions and include other elements that are associated with greenhouse gas emissions. Two other elements we looked at were the boundary, and here you see that many of them, all of them include the building itself, but some frameworks include embodied carbon and the kind of emissions associated with the materials within the building, structure, building enclosure, foundations. And then things like certifications like LEED Zero Carbon include transportation and the emissions associated with transportation, which prioritize projects that are located in a city center where people can use smart forms of and low carbon forms of transportation. Another factor that has been hotly debated for a long time, and we're seeing a big push towards, is beneficial electrification, and really removing the use of combustion or fossil fuels on site. You see different local jurisdictions around the country basically kind of banning the use of natural gas, and a big push towards electrifying, using electric systems for heating, cooling, ventilation, and other uses throughout buildings. The ILO 5 certifications effectively don't allow combustion. Other certifications do, but we're seeing a lot of change in this space. And I anticipate that there's going to be more and more of a push towards defining net zero by not using fossil fuels on site. There is also a big push towards requiring efficiency and ensuring that people aren't just installing a bunch of renewable energy on or off site or buying offsets, but making sure that the building energy use and loads are significantly reduced. And so these frameworks, a number of them require certain energy efficiency standards. And some of those are based on specific codes or existing building metrics like CBEX. Others, like the LEED Zero frameworks, don't have a specific energy efficiency requirement, but require that you achieve LEED certification, which is associated generally with more energy efficient buildings. We also see some variation in terms of whether off-site renewable energy is allowed. And this is also a topic that has been hotly debated for quite a while. We're seeing, I'd say, more expansive approaches to thinking about community solar projects and supporting buildings with solar and renewable energy assets that are not on site. I am based in New York City, and this is critically important for projects in New York City. There's no way you can put enough solar on a building in Midtown Manhattan to make it net zero. But some buildings in New York City can buy into a community solar project that helps effectively make it net zero carbon, and in some cases net zero energy. And then last, there are a number of other elements that are associated with carbon emissions. Looking at grid integration and real-time carbon emissions and how that impacts overall emissions for the project. So incorporating time of use options, also looking at embodied carbon, which is a big focus for a lot of folks right now, and understanding how to prioritize and value on-site and off-site renewables. And there are details in the guide about these. So just a quick note, Webley and others will talk about these in a few minutes, but they're the core components and additional components of carbon neutral buildings are really good. And what I would say is that on any one project, you may or may not be looking at all of these, but there's no way that we can get to carbon neutrality by 2050, 2040, or before without doing every one of these, the core and the additional components. And the way we tend to frame these is looking at how all of them interact in specific buildings to get to a zero carbon building. And again, that includes what's happening within the building as well as what's happening within the grid. So with that, I'll pass it back to, I think, Webley.
Great, thanks, Narda. Do you have one more slide there?
No, you can go to the next slide.
Okay. So hi, everyone. My name is Webley Bowles. I am a project manager at New Buildings Institute. I work in the Getting to Zero and the Codes and Policies program areas. Give me a minute. There we go. So we have developed this guide, the Insider's Guide to Talking About Carbon Neutral Buildings, as a way to pare down the main elements of carbon neutral buildings and help clarify some concepts. Our intent is not to define carbon neutral per se, but to help communicate what should be known about the topic at a high level. So I think Narda kind of introduced us to it. And I really appreciate that. So we'll dive just a little bit deeper. We know that we have seen utility programs that have been focusing on energy efficiency for years. They've been leading the market towards lower energy efficiency buildings, and that's been great, right? But the building sector is really shifting from decades of this KWH and therms to more government action, which is centered on global greenhouse gas emissions, GHG emissions. And what you see on the right here is from Eugene, Oregon's climate action plan. And what you see on the left is an incentive program. So we're trying to figure out, how do we align these two things? And I realize it's not advancing. There we go. So on the right is the Eugene, Oregon's climate action plan, and on the left is Xcel Energy's incentive program. So we thought that we could come up with a definition that helped link the different ideas, but we saw that there was more of a need for a framework because carbon's a little bit shifty. Are we talking about operational carbon, upfront embodied carbon, whole life? Narda kind of showed us around the table, you bring up this topic, it's not just a simple like, okay, cool, let's go. There's a lot of questions around it. So it's the difference between looking at graphite and diamonds. So both of them are carbon, right? But those are not equal. Those are very different elements. And we need to define those. So when we talked about net zero years ago in zero energy, we kind of came to the same place of like, what is the definition, right? And what we understand is that we really need to define what is graphite and what is diamond, so we know that we're talking about something similar. And went too far. There we go. So this is a graph from WSP, which we really appreciate that they developed. We were doing similar research where we had looked at these different definitions. They were doing something similar. We're trying to find the similarities and differences between what is carbon neutral. How were they representing embodied carbon, on-site combustion? How are renewables defined? As Narda mentioned, it's kind of a hot topic. Do we allow offsets? Do we not allow offsets? Does it have to be renewable energy only? There's a lot of questions there. And while all these details really vary, there's a lot of commonalities. And the divergence is really in the details. So these are what we call our core components and additional components. And we split these into two groups for a reason. So when we first look at the items on the left, the core components of carbon neutral buildings, you'll see that they're very similar to zero energy buildings. We have energy efficiency, renewables, on-site renewables, off-site renewables, in measuring and managing carbon neutral operations. I've got a spastic mouse here. What's happening? Okay, when we look at the additional components, these are the things that will lead us to carbon neutral buildings. While the core components are still essential, we want to move towards looking at carbon. So electrification, building grid integration strategies, low global warming potential refrigerants, and embodied carbon. Before I go on, I do want to note that it's important to remember that these are all at a very high level. There can and will be entire books that are written about each of these topics. This guide is intentionally high level, as every organization, program, project will have their own goals and objectives that will change the details for all of these. There we go. So these are the first four components: efficiency, on and off-site renewables, and measuring and managing carbon neutral operations. So you're familiar with these. Hopefully, if you're familiar with zero energy buildings, I won't spend too much time on them. I do want to make a couple of points here and say that energy efficiency is still essential. As Narda showed in that graph, he was showing that to get to carbon neutral, it's 30% or more energy efficiency. It's still really important. On and off-site renewables are going to be different for every project. We know not everyone can do on-site renewables, so we need to consider how we're allowing for off-site renewables. and they're becoming more common and in high demand. In Utah, there's actually more of a demand for offsite renewables than can actually be built at this point. So there's a great opportunity, business opportunity there. When we look at the additional components, we see that building electrification, building grid integration, energy storage, low global warming potential refrigerants, and low embodied carbon materials are all there. And these components ask us to think past the property line. For example, when we're talking about building electrification, there has been getting more attention around this lately, and it's important, and it will continue to rise, because with electrification and electrification ready, it's preparing us for this carbon neutral future. As the grid uses more renewable energy, our building emissions will be reduced. So not all buildings are going to be able to go 100% all electric, so we need to have some opportunities for getting there in the future and making that transition a little bit easier. So I'll address the last two components at a high level still. Since they're a little bit new, but not really, they're getting a little bit more attention. So refrigerant global warming potential, or GWP, it's been considered at the international level since the 90s. So again, not new, but we're bringing more attention to it. And there's been more regulation for years around the ozone depleting potential and global warming potential from these refrigerants. But there's still opportunities to continue to reduce the emissions from the refrigerants, especially with the rise in heat pumps for heating and cooling and water heating. We're going to be using more refrigerants in these systems, and so we need to find ways that we can reduce our emissions around them. 1 pound of R401A is about equivalent to 2 tons of CO2. So these refrigerants are, while we're using a small amount of them, they are really important. Some lower global warming potential refrigerants are slightly flammable, so it's important consideration to take, and we'll be addressing this in codes. So they can't necessarily be swapped for one refrigerant without some modifications. And we're also going to be seeing some leak detection around this, because with not just because of the flammability issue, but also with the leak of refrigerants. We want to make sure that we're keeping an eye on that. Low embodied carbon materials is another place where we've been discussing it for years, 20+ years, but there's been a new spotlight on these high impact materials. So as buildings are becoming more efficient, energy efficient, we are seeing that the materials are making up a larger percentage of the total carbon. In some cases, up to 50% of the total carbon of a project is coming from materials. So this is another area where we can play the same name game and talk about upfront embodied carbon, operational embodied carbon. We can talk about whole life embodied carbon as well. So again, many other resources will help support projects around these different terms. As building codes start to address carbon and not just energy, designers are going to have to become more familiar with reducing embodied carbon, and concrete and steel are the best places to start at this point. So I hate not telling you every single detail about these components. This guide is high level. We have references in it. There's hundreds of considerations on these topics that will be addressed by different programs, project boundaries, tools for converting energy to CO2e, regional energy sources and the carbon intensity based on time of use, and all other really nerdy details. And my colleague Misha will get into some of these fun details next. So I'm excited for her to present that. But before I leave, I do want to state that, oh, I go too far. I do want to let you know that no matter what you're calling your building, whether it's net zero, carbon neutral, zero carbon, it's important to know what components you're addressing, but more importantly, it's important to know what important components you're not addressing in your project. So not all projects can address all components for whatever site constraints there are, but it's important to consider how these can be addressed in the future, because the future is really what we're building about. We're all trying to move to a carbon neutral future. How can we do that? And these 8 components can help us get there. So thank you, and I'll hand it over to Misha.
Thanks, Webley. Good morning and good afternoon, everyone. My name is Misha Egolf, and I am a project analyst for the Building Innovation team at NBI. So I'm going to provide some additional details on the great information that Webley and Narda already provided, and specifically talk about how zero carbon goes kind of beyond zero energy, and how the times that the building is actually using energy affects their ability to reach zero carbon. So as some of you may know, NBI hosts the Getting to Zero database, which is a comprehensive list of zero energy commercial and multifamily buildings across North America. As you can see here, we have projects all across the country. We actually have over 700 projects. So this isn't something that happened overnight. We've seen a lot of growth since we launched the database. As you can see here, we went from just 60 buildings in 2012 to more than 700 buildings now today. So as Webley said, this is attributable to decades of regulation and programs oriented towards energy efficiency. But as you all know, in recent years, we've seen a shift in the building sector to also emphasize carbon and greenhouse gas emission reductions. So as we look at both zero energy and zero carbon buildings, it's important to understand the difference between the two. And I want to show you guys some examples. So the graphic here is showing an example of a ASHRAE 90.1 2004 compliant medium office prototype building in Washington State. That's where I'm located, so I'm partial to this example. This is an all-electric building prototype. And so the blue line is showing the building's operational carbon emissions, just kind of the baseline prototype building. So then the green line is showing if you add on-site solar, which covers 100% of the building's energy use, so you're making it a zero energy building, you can see that this does significantly decrease the carbon emissions, but it isn't enough for the building to be considered zero carbon. So you can see that the areas above the zero line are still a little bit more than the areas below. So why is this the case? Let's take a step back, and I'm going to revisit some of the components of a zero energy building and a zero carbon building, and some of those considerations that Webley was mentioning. So as we've talked about, when you're looking at a zero energy building, the key components are maximizing energy efficiency, looking at on-site and off-site renewables, and really streamlining your site operations and keeping an eye on those and fine-tuning them. When you start to look at zero carbon as well, you have to expand your scope. As Webley and Narda mentioned, you have to start looking at grid integration and on-site storage, whether or not you have on-site combustion of fossil fuels, what kind of refrigerants you're using, and the embodied carbon of the materials you choose. And then there's also all of these additional considerations that Webley mentioned, like where your project boundary is defined, the methodology that you're using to come up with your carbon equivalencies, the transportation around the site, the full life cycle of the materials, and lastly, the time that you're actually using energy and the impact to the regional grid. So I'm not going to go through all of these in detail. Like Webley said, we have a short amount of time today, so I can't take a deep dive, but just trying to illustrate some of those additional considerations and some of the questions that those raise. So for example, if you're looking at your project boundary, are you looking at a single building? Or let's say you're on a higher education campus, are you looking at the entire campus? Obviously, reaching zero carbon looks different for each of those scenarios. And as you move through all these questions, as Webley mentioned, you have to think about not just your operational carbon, but embodied carbon as well. I think that that's particularly important when you're thinking about the life cycle of your materials. So how will the materials be handled at the end of their useful life? Are you going to upcycle, reuse, or recycle, or is it just going to the landfill? I'll also just mention that, the methodology that you use to convert your energy use to a carbon equivalency, those calculation requirements vary by program and jurisdiction. It also is going to make a difference if you're looking at your predicted energy use or actual performance-based, hard numbers. So there's a lot of things to think about, a lot of questions, but I'm going to take a little bit of a deeper dive into this idea of your time of energy use and the regional grid impacts there. So to understand this dynamic between energy and carbon, you first have to, kind of recognize that greenhouse gas intensity varies hourly, daily, and seasonally, depending on the generation sources that are being utilized. So I have an example here of the projected 2030 grid. So this is provided by NREL in their Cambium data set. This is a forecast, basically. And so this is their long run marginal carbon metric. So I have here the state of California, and then the Seattle area, once again, Washingtonian here. The green areas indicate lower carbon times, or what you could think about as a cleaner grid. So that could mean more renewables or hydro online. And then the black areas are when the grid is the dirtiest, so when generation is predominantly from fossil fuels. So you can see that in California, all throughout the year, January through December, you have in the mornings and in the evenings, you're going to have higher carbon generally. And in the middle of the day, predominantly solar is available. So you're going to have lower carbon because that's the generation source that's being pulled. For Seattle, it's interesting. It looks a little bit different. We have a lot more renewables, hydro here in the summer and spring. And then so you can see that the grid is a lot cleaner kind of all throughout the day in those months. But then especially as you look at like January, the grid really changes. So I think this is a good representation of kind of the variation that we're working with here. So returning to the energy use versus carbon concept, I have here a load profile for that same prototype building. So that's this all electric medium office building here in Washington. And you can see that on average in the month of January, so again, I have that heat map showing what the January grid looks like. The building demand is really high, which is the blue line, right when the carbon is also nearly at its highest point. So this is, kind of a monthly average. So obviously this isn't an exact number, but just to give you an idea of the shape we're looking at here. So this means that, you're not really saving anything in terms of carbon. So we say, okay, let's add some on-site solar and see how that affects the picture. So we see here that the building's peak is still happening in the early morning when grid carbon is high. So we're decreasing our load quite a bit midday when the sun is out. But in the case of the Seattle grid specifically, that really isn't helping with your operational carbon. So you're definitely going to save money on your electric bill, but you may not see a significant decrease in your operational carbon emissions. So that's just one quick illustration, but I guess I just really want to emphasize that every grid is a little bit different and every building is a little bit different. As I mentioned, the building vintage and the building type are going to change things. The grid that you're in, the grid region, and where that generation is coming from are all going to be variables. So in this graphic, I did just want to zoom out a little bit and show that for this analysis that NBI conducted, we found that what it takes to reach zero carbon operations is pretty variable. So the dashed line is showing the threshold for zero energy operations in this all electric building scenario. So you can see from this chart that depending on the grid region, you can actually reach zero operational carbon before you reach zero energy in some cases. But in other cases, you need to over-generate to reach zero carbon. So you're seeing some of that here where you have to produce a lot more energy in some of these cleaner grids. So to wrap up, reaching zero carbon is totally possible. We saw that on the previous slide. It's just a question of how to get there. And this thinking about this concept of when you're using energy in the building is really important. So there's a lot of solutions, as both Narda and Webley have hit on some of those. But as Webley said, maximizing energy efficiency is going to continue to be really important, and especially energy efficiency that's really focused on time of use. So if you can tune your building through time of use measures to take advantage of abundant clean energy when it's available, and then perhaps coast through the times when the grid is really dirty by adding storage, you're going to be well on your way. That's potentially a really winning strategy. So that's all I've got for you today, all the time I've got today. But I thank you all for your time, and I'll pass it to John.
Great, thank you, Misha. See if I've got control over the screen yet. Yes. So my name's Jonathan Heller. I'm the president of Ecotope here in Seattle. We're an engineering and research firm, and I am going to take us a step down into the buildings and talk more about what the things that the previous three speakers have been talking about. What does that mean in a building? What does that mean for a specific technology and a specific case study in a building? So Ecotope is a mission-driven company focused on leading the transformation of buildings to carbon neutral buildings. And we've organized ourselves around three of the responses to the climate crisis that have been mentioned previously. The first is stop burning fossil fuels in our buildings and shift to high efficiency heat pump equipment instead. The next is still that focus on energy efficiency with our designs so that we can shift electric usage to run our transportation sector and to make up for all of that fossil fuels that we're now going to be running on efficient heat pump equipment. And third, this what Misha was just talking about, changing the relationship between our buildings so that it's not, and the grid, so that it's not just a one-way relationship where, like we're used to, where you flip a switch and expect to get power whenever you want it, to a two-way relationship so that the buildings start to tune their use of energy with when the grid is clean and when solar and wind are available on the grid, and not use energy when the grid is dominated by fossil fuel usage. And in the future, we'll see this through on-site battery storage and potentially in our vehicles, feeding back to run our buildings off of the vehicle batteries, to large amounts of thermal storage located in the buildings for use at a later time. So to bring this into a case study, all three of those primary responses to the climate crisis come together in the work that we have been leading around the commercial heat pump water heater product development in the Advanced Water Heating Initiative led by NBI. So the vision for this technology is that we are changing the standard practice of heating water in multifamily and commercial buildings with gas to using commercial heat pump water heater systems that are able to deliver COPs of 3 or better, so using a third or a quarter of the energy of a gas system or electric resistance system. Using low global warming potential refrigerants in those heat pumps, delivering them to the market in a plug and play fashion so that they're easy for the designers and installers to get into the buildings. They're affordable, they're reliable, and they have this ability to shift the load off of the peak times. And right now we're really focusing on this plug and play concept because we're trying to shift. Commercial heat pump water heaters have been around for quite a long time, but have made very little impact on the commercial building market, primarily because the heat pump manufacturers have been selling heat pumps that require specialized knowledge on the part of the designers and installers to build up a custom system within a building to use that product. And so we're trying to shift the manufacturers and the supply chain from selling heat pumps to selling water heating systems. And the system includes all of the components that you would need for a fully functioning water heating system. Deliver that in a way to the marketplace that it reduces the risk for the designer and installer and owner. It's able to get reliable, repeatable results every time, and we begin to bring the price down and the reliability up of those systems. So this is a picture of what one of these systems might look like in a large multifamily building down in the parking garage. And looking at it, it looks like a very complex system with a lot of moving parts. But what I want to convince everybody is that everybody kind of knows what a residential heat pump water heater is, and the commercial systems include all of the same parts and pieces that you would see there. They include the compressor, the heat pump that in a residential product sits on top of the tank, and you can see the heat pumps there on the left of the lower photo. It includes a storage tank to store the hot water. It includes a backup heat or temperature maintenance heater or supplemental heater, and it includes a controls package. So all of those parts and pieces are the same as what you would see in a residential heat pump water heater. And what we're beginning to see in the industry is packaging up all of those parts and pieces for the larger complex system into a single package so that it can be delivered to the marketplace in much the same way that the residential heat pump water heaters are, as a full package that can be dropped on the roof and connect the water and connect the power, and you've got your water heating system. And so, some of the systems will continue to be delivered in what I kind of am calling the IKEA approach, where you get all of the parts and pieces that are needed and assemble them on site, but really trying to shift the thinking in the industry from heat pumps to water heating systems. And we've worked with the Northwest Energy Efficiency Alliance, which has managed a advanced water heating specification for residential equipment for several years, and added a commercial section to that specification. So we'll have a qualified products list of fully integrated commercial heat pump water heater systems that can be rated with different equipment in different climate zones under different configurations will give you different results. And this specification will be a tool for the industry, for the utilities, for the designers to compare these different systems. And then the other aspect of these systems that Misha was talking about, that the commercial heat pump water heater systems lend themselves to well, is this concept of load shifting. So the graph that you see there is a typical multifamily hot water demand, which has a large peak in the morning when everybody's getting up and taking showers, and then another peak in the afternoon when people are making dinner and washing dishes. And the water heating systems tend to operate, traditional water heating systems tend to operate in response to those peaks, which, as Misha pointed out, is typically when the grid is the dirtiest, because that's when everybody wants power and you need to turn on your fossil fuel generating facilities. So what we can do by focusing on storage and smaller capacity and more volumetric storage is shift that when we operate the water heating systems into the cleaner times of the grid. So a case study of this equipment that we've just completed here in Seattle is at the Bayview Tower, which is owned by the Seattle Housing Authority. It's a affordable housing project, 11 stories, 100 multifamily units with an existing electric resistance water heating system, central water boilers, fully occupied building in a tight urban setting. And we wanted to retrofit the building to use a commercial heat pump water heater system. So we couldn't turn the water off for any significant amount of time because it's a fully occupied building, and it's a very tight site, so there's not a lot of place to work with. So we've been working with Mitsubishi Electric to import a new to the US CO2 heat pump water heating system. So it's using CO2 as the refrigerant as opposed to one of the higher global warming potential refrigerants that are more typical in this equipment in the US. And worked with them to package it up with storage controls and design schematic to make it all work as a package. And then worked with a third-party assembler, Steffes, to build it into a pre-manufactured package to deliver to the site. And these are some pictures of them building that up in their factory. And then we packaged it up into an insulated, effectively a penthouse that includes all of the parts and pieces needed for a water heating system, and craned it up onto the roof and made the switch over from the existing water heating system to this new heat pump water heating system. In this case, since it was a retrofit, we left the existing system in place as backup, and it allowed for that just a couple hours of switchover time needed, so the residents never really knew that it was happening. This product is in development to be sold to the marketplace in the US, and the Mitsubishi product will also be available in that IKEA approach, with all the parts and pieces to be assembled on site if that's what the designer and installer prefers. But this is making the implementation of these systems much easier, so that we can have a low global warming potential refrigerant, highly efficient heat pump that is capable of load shifting, made available to the market in an affordable and plug and play fashion. That's all I've got, and I think we'll open it up for questions now.
That's great. Thanks, everybody. I'd like to have my presenters go ahead and turn on their camera. All right. Almost there. Excellent. Hey, John, we're going to go ahead and start with you with a question. Let's see. How many, if you know, how many manufacturers are using CO2 as a refrigerant at this time?
In the US, there's 2 that have been on the market for a little while. Sanco 2, previously known as Sandin in the US, has had a small residential product, but we have been the slide I showed earlier of the water drop is an example of that. That uses the Sandin engine to produce a fully packaged commercial product, or those can be built up on site with multiple of those smaller components. Mitsubishi is having their launch, I believe, in October of that product that you see in the photo there still. That's the QAHV. Link has brought a product to the US recently. They're owned under the Watts. The Watts is the parent family in the US, and they sell all kinds of plumbing equipment. So they're going to be selling a complete package, including storage and so forth. So those are the, and then there's Mayakawa has been around in the US for quite a long time. They have not focused on potable water systems. They're a much larger product that's really more appropriate for industrial applications, but we've seen a little bit of movement to try to use that product for multifamily water heating as well. So there's 3-ish products in the US market right now.
Okay, thank you. We had a question about, let's see, LEED energy or carbon, zero certification programs. Is there anything specific about hydropower as an energy source in the LEED systems that you all know about? Or would that just be grid?
Turning on, yeah, I'm turning on my
energy.
Yeah, so a couple things. I'm looking at some of my notes here. So that would be associated with the carbon emissions of the grid. And when we look at LEED Zero Energy, that is looking at source energy use, and LEED Carbon looks at CO2 emissions. So if you're in a grid region that has a lot of hydropower or other low carbon production, that would effectively reduce the carbon emissions associated with the electricity within that grid and could lead to lower overall emissions for a building within that grid. So in the Northwest and upstate New York, in the Northeast areas that tap into a lot of hydro, the grid emissions are lower and could be captured in the LEED framework.
Awesome. Any other additions?
Connie, was that question about individual projects or the grid?
It didn't specify. It was
Okay.
just about how hydro impacts the LEED carbon.
Yeah, I guess just to follow up on that, if you are looking at site energy and just the amount of renewable energy produced on site and the amount of energy that your building is using on site and not really looking at the grid, then hydro, whether the grid is supplied with hydro energy, is not really going to be a factor. But if the framework includes grid emissions, then hydro will likely be a factor because that will contribute to a lower carbon grid.
Great. John, we have another question on the heat pump water heaters. For CO2 as a refrigerant, is an additive used to cause it to be detectable via smell? And also, are leak detection requirements similar to other refrigerants, or are they more or less stringent?
Yeah, leakage from a CO2 product is much less of a concern than leakage from one of the other refrigerants. There's a very small amount of CO2 in these products. So it's not really dangerous, and they have not included any smell detection in that. They're installed outdoors typically, so if it did leak, it would just stop working, and it's a very small amount of carbon released to the atmosphere.
Okay. We had just another quick question. There are pictures of plants on the roofs in some of the diagrams today, but they didn't hear any discussion of it. Is it useful?
Webley,
Say
you want
that-
to take that one?
Yeah, I'll say that plants are nice. Plants can help meet design goals. I don't think that plants are essential to any of the core components. They're kind of a nice to have. It's a design consideration. In some cases, it can provide added insulation on your roof. If you have, more soil on the roof, it's adding more insulation. It can also cause some problems with structure and leaks and whatnot. But I wouldn't say that it's an essential item. It's a nice to have. Plants are great.
Yeah, just because there are plants on the roof doesn't mean it's a carbon neutral building. You could have a building with a lot of emissions and plants on the roof, and one with no plants on the roof that is net positive. So they're not typically, directly associated with whether they're net zero energy or carbon.
I wonder if the question is getting at whether or not the carbon uptake of the plants themselves is measurable in comparison to the carbon impact of the building.
There's
Apparently.
no detail.
That's probably a whole nother webinar. There are some carbon, there is some carbon uptake associated with plants, but what happens when they decompose and how they potentially go back into the ground or not is part of the equation.
Yeah, those start getting to those real small details of what do you calculate and how do you calculate it, and what do you calculate the upfront or the whole life emissions of a plant. We're talking about buildings, but yeah, it's something to consider.
All right. Well, thank you, everyone. That was a fantastic presentation. So we are closing up here. Just a last couple slides. The Getting to Zero Forum has gone hybrid. There are now opportunities to attend in person and online. If you plan on joining us in New York City in October, please make sure to have your room booked by October 4th. You can visit the Getting to Zero Resource Hub to check out over 300 resources on zero energy and carbon neutral buildings in 6 categories. The website is there. Find out first, join us on social media. We have a new Instagram account if you haven't seen. And I want to thank our presenters for their time. Thank you, all of you, for joining us on the session. And please make sure to fill out your survey if you're seeking AIA credits. Stay safe and stay well. Thank you, everybody.
Thanks, everyone.
Bye, thanks for listening.
Thank you.
Have a nice rest of your day.